Hey guys, so this video is going to go over sinusoidal functions, day 2. We're on page 22. I'm going to do number 1 with you, that's on this page. Number 2 I'm going to leave for us to do in class. So number 1, actually go ahead and pause the video right now, go ahead and read what's given. I'm going to jump right in. We're given that Mr. Wernow has buried some treasure in a mountain, in the side of a mountain. And so we have a valley that's to the left of this mountain that's filled with water. So we're dealing with not only the mountain but also a valley and water and all that kind of stuff. So we do have the depth of water, and so we're dealing with water's level. So if you keep reading, it does say that you set up an x-axis at water level. So if I make an x on my x-axis on my graph, I need to first of all realize that the x-axis is going to be your water level. And so I'm going to say that this is, I'm going to label it so I don't forget later. This is the water level. And it is in meters. If you keep reading, you'll find that this is in meters. And the y-axis will represent the height of the mountain or the depth that we're dealing with. So I'm going to say that this will be the depth, also in meters. In case you need to know, the x values themselves will actually be the distance away from the location that we're dealing with. So now if I jump right in and I look at the information that's given to me, I know that the depth of the water is 50 meters. What that means is the lowest, the water that we're working with, the lowest point we're dealing with is at negative 50. The lowest point is at negative 50. And the top of the range, the top of the mountain, is 150 meters above water's level. So if this is my water's level, then 150 is the highest that we're gonna go, the highest we're gonna go. So we set up the x-axis at water's level, and it says that the y-axis, now be careful here, it says the y-axis itself is 200 meters to the right of the deepest part of the water. The y-axis is to the right, which means that at negative 200, you have the lowest point, the deepest part of the water is right there, which tells you that the y-axis is actually 200 meters to the right of that point of the deepest part. So the deepest part of the water is at negative 200, negative 50. So we have our low point. Now if I keep reading, it tells me that the top of the mountain is at x equals 400. So x value is 400. And since that's the top of the mountain, I know that the highest we're going to go is 150 feet, so there's my highest point. So now that's actually all the information that's given. Let me see what I can do with that. So if I know this is my lowest, and I know this is my highest, and I know these functions continue because they're sinusoidal, I'm just going to draw arrows to represent that. Now, we're actually, believe it or not, we're actually given enough information. We do have enough. Because we're given a low point and a high point, we will have to do some inferences of what the rest of it looks like, because we're actually given half of the entire pattern. Half of the entire pattern is given. So if I take a look at from the lowest to the highest point, there's a distance, there's a total distance of 600 meters. Now that's only half of the entire pattern, and the reason why I'm looking for the entire pattern is because remember, one entire pattern, or the time it takes, or the distance it takes to complete one pattern is your period. So now I'm going to go from here, and I'm going to say if up to here is 600, then double that will give me one entire period, which double 600 is going to be 1200 meters. So now I know the period is 1200 meters, and I know I can use that later. So I'm going to circle that so I know to come back to it. Now the other thing I can find on my graph is the center line. Remember, the center line does also come up when you're writing the equation. So if I know that my highest point is at 150, and I know my lowest point is at negative 50, then I know my total distance is 200. Now, to find the center line, I actually need to find the middle of that distance, half of that distance. So half of that distance would be 100. Now I need 100 down from 150, which is going to be at positive 50. So I know all my midpoints are going to be located at on that line, on 50. So this is my center line, which, remember, is your D value. So D is going to be 50. D is always based on the center line. That's probably the easiest value to find. Okay, so now I have my graph. Now let me go into writing my equation. Remember, there are 4 transformations that we have to hunt for based on the information given. And I do want to write this equation expressing y in terms of x. Now all that means is just, instead of writing theta like we normally do, just write x. That's all that means. Okay, so let's go through and find everything that we can. A, remember, is amplitude, and the definition of amplitude is the distance from the center to the highest. So just like we mentioned earlier, that distance from the center to the highest is simply 100. And that's going to go right before cos. Okay, B, I can't really find just by looking at the graph, but I can find B based on the period. So if I know that period is 2 pi over B, I can plug in what I know to find what I don't. I know the period is 1,200 meters, just like we found earlier, and I don't know B, but I can find B by putting 1,200 over 1 and then cross multiplying. So if I have 1,200 B equals 2 pi, I'll divide by 1,200 on both sides to get B by itself. And if you simplify that, you'll have B equals pi over 600. So there's that. Now B is pi over 600. And remember, that goes right after cos. It's pi over 600. Now C, remember, is a phase shift. Because we're calling this a cosine function, you want to look for a high point that's closest to the y-axis. And the one that's most visible to me, because there's no other points really, I just have a low point and a high point, that high point is 400 meters away from the y-axis where it normally is. So we're going to say then that the C value is to the right 400 meters. Now, since it's to the right, I'm going to write down minus 400, and just don't forget your parentheses. Otherwise, we're going to probably forget them in the calculator, and that's not good. So now I will need to find my D value, and like I said earlier, remember, D is exactly where your center line is located, which is at 50, positive 50. So we'll write down plus 50 at the end. So there's my equation done. Now, part B is asking you to find a short way, the shortest way, to get to the treasure if the treasure is located exactly at this point. 130, 40. So now let's take a look at the graph again. So if I have my graph that looks like this, and this is just a sketch, so forgive me, but if this is my highest point, here's my lowest, and it says that the treasure is exactly at 130, and so I'm just going to kind of estimate here, 130, 40, and my treasure is right over there. What's the shortest way to dig to the treasure? Is it better to dig horizontally from the side to get to it, or is it better to dig vertically and get to it that way? So what's the shortest way? That's what we're looking for. So we have to actually do this 2 different ways. We have to see what is that distance vertically and what is the distance horizontally, and then we'll have to decide, okay, what's the shortest way to get at that treasure, right? So let's go ahead and do the vertical. Let's look for that vertical distance first. So we'll do vertical. And because we're looking for a vertical value, we're looking for y. We don't know y, okay? But we do know x. X is 130. For that location where Our gold is where the treasure is. Our X value is 130, but we don't know Y, okay? We don't know the Y value. So what we're gonna do is, because we know X, we're gonna throw the X into our function to find the Y value. So we're going to go into the calculator, and just like we did on the day 1 video, we're gonna type in the equation first. So I'm gonna go to graph, and right over here I'm gonna type in 100 cos of open parenthesis pi over 600 close parenthesis open parenthesis x minus 400 close parenthesis and plus 50 at the end. And if I hit enter, it should give me that graph. Okay, so now notice it is a straight line, and sometimes when you graph these, you have weird looking things that pop up into your screen. So of course we do have to change the window. So I'm going to go to menu, and I'm going to go to zoom out. Now there are several different ways to do this on the Inspire, and I will show you different ways to do this as we move on, just so you know. Now notice the more I zoom out, the more of the curve I actually start seeing. Let me actually move this label out of the way. It's kind of getting in my way. Okay, so now we have our sine curve, or our cos curve. Now what I'm going to do is, because I want the Y value given an X, remember from the first video, I'm going to go to menu, I'm going to go down to trace, graph trace, and I'm going to type in the Y value that I have, 130, hit enter. And here at the bottom it gives me that when X is 130, Y is 65.6. 65.6, and that's meters since it's your Y value. Now that is the Y value from the axis. Now we don't want all of this, because we know from the from the x-axis up until that x we know is 40. So really what we want is, I'm going to say the vertical distance is really going to be this amount, which is all of this. That's what we just found, 65.6, and we're going to subtract from it the bit that we know, which is 40. So that gives me 25.6 meters. So that's how much you would have to dig if you dig into the treasure from the top vertically. Okay, so now let's move on. Let's do we'll go on and find the horizontal. So if you were to instead dig into the treasure horizontally, what we're looking for now, because we're looking horizontal, we don't know X, but we do know Y is 40 based on the point that was given. So if I know Y, I don't know X, really this is what we have. Okay, where Y is given to be 40. So now I'm going to go into my graph and I'm going to hit tab, because now it pulls up a spot for me to type in Y equals 40, hit enter. And so it drew me a line. Now I want the intersection, so really I want that intersection right over there. So I'm going to go to menu, I'm going to go down to analyze graph, down to intersection, and just like we did last time, because that's the intersection I want, I'm going to go a little bit to the left of that, hit enter, and then I'm going to go a little bit to the right of that for the upper bound. There we go. There's your intersection right there. It's highlighted. Okay, and again, not sure if you can see that, but it says that when Y is 40, your X value is 80.9. So X is 80.9 meters. Now again, that is the entire distance from the axis to the treasure. Now again, I don't want all of that, because I know that all of this is already given. I just want from the mountain to the X. That's all I want. So I'm going to take So the horizontal distance is going to be 130 minus 80.9 to give us 49.1 meters. So now we can compare the two. Obviously, the shortest way to get to the treasure is by digging vertically. So we're going to say this one is better. Vertical is better. It's the quickest way to get to the treasure. Thanks, guys.